Welcome to The Explainer. Today, we're embarking on what is honestly a true cosmic detective story. We are unraveling the absolute mystery of Oumuamua, which is literally the very first confirmed interstellar object to ever visit our solar system. It's a story of discovery that totally challenged everything we thought we knew about the objects wandering the dark expanses of our galaxy.
So I want you to imagine for a moment stepping into the shoes of a cosmic detective. The stakes here are immense. You've got this unexpected, incredibly fast object zooming through the lenses of our most powerful observatories. Now, out in the vast dark of space, it just looked like a single tiny point of light, but it held secrets from way beyond our sun. So what exactly happens when an intruder from another star system just crashes right through our cosmic neighborhood? Well, let's find out.
Okay, let's dive into Section 1. A visitor from beyond. It all kicked off on October 19, 2017, when a Canadian astronomer spotted something that just completely defied the normal rules of celestial mechanics.
Recognizing just how unprecedented this was, the Pan-STARRS team gave it this really beautiful Hawaiian name, ʻOumuamua, and that roughly translates to a messenger from afar arriving first. I mean, think about the sheer excitement of that moment. Scientists realized almost immediately we weren't just looking at another local asteroid or a standard comet. No, we were looking at a relic from way beyond our own solar system. It's a traveler that had likely been wandering the Milky Way, totally unattached to any star, for hundreds of millions of years.
Now, the timeline of how it passed by us is kind of fascinating. On September 9, 2017, Oumuamua reached perihelion. That's its closest point to our sun, diving right inside the orbit of Mercury. Then on October 14th, it made its closest approach to Earth, zooming by at about 15 million miles away. But here's the kicker. It wasn't even discovered until October 19. It's incredibly ironic, right? Humanity didn't even notice this interstellar messenger until it had already swung past us and was racing away back into the cold, dark void.
So how were scientists absolutely certain it was from another star? Well, 196,000 miles per hour. That's about 87.3 kilometers every single second. I really want you to grasp that number. That was its blistering speed at perihelion. This extreme velocity was the smoking gun. It definitively proved the object had a strongly hyperbolic trajectory. Put simply, it was moving way too fast to ever be captured by our sun's gravity. It was basically a one-time visitor that plunged in from above, used our sun for a quick gravity assist, and slingshotted its way back out.
Let's move to Section 2, the bizarre physical clues. As Oumuamua was speeding away, there was this urgent, global scramble to bring our biggest telescopes online to look at it. But remember the challenge here. We essentially only had a single pixel of light to work with. And this brilliantly illustrates the whole deduction process astronomers use to solve the puzzle. First, they watched the object's brightness changing dramatically. I mean, it was getting brighter and dimmer by a factor of 10 every 7.3 hours. Next, by calculating those light curves, they mapped its rotation, and they figured out that it wasn't just spinning normally, it was tumbling chaotically through space. Finally, they concluded it had a highly elongated shape, possibly up to a 10-to-1 ratio. So it wasn't spherical like most asteroids. It was either shaped like a long cigar or maybe a flat pancake. We had literally never seen a natural object with such extreme proportions in our solar system before. Then there was the clue of its color. Spectroscopic analysis showed that its surface was pretty featureless, but it had a very distinct reddish hue. And that coloring tells us about the presence of tholins. Tholins are these irradiated organic compounds that are super common in the outer reaches of solar systems. This gave scientists a huge piece of the backstory. Hundreds of millions of years of exposure to harsh cosmic rays had basically baked its surface red. And this dense, rocky, or maybe metallic crust might actually be acting like a shield, hiding a deep, icy interior and insulating it from the intense heat of our sun.
This brings us to a highly perplexing phase of our investigation, Section 3, Anomalies and Acceleration. Because right when astronomers thought they kind of had a handle on Oumuamua's physical profile, the object had a bit of an identity crisis.
To really understand why it was so incredibly confusing, we need to quickly contrast our typical solar system bodies. On one hand, you have comets. Comets are icy bodies, right? When they get near the sun, they heat up, they produce visible comas, that fuzzy atmosphere, and those iconic long tails. That vaporization process, called outgassing, actually acts like a natural thruster, which causes the comet to accelerate. Asteroids, on the flip side, are rocky or metallic, and they're completely inert. No comas, and their movement is dictated entirely by the gravity of the sun and the planets.
So the crucial point is this.
Oumuamua actually accelerated by about 17 meters per second beyond what the sun's gravity alone could account for. It behaved exactly like a comet getting pushed by the outgassing jets of melting ice. But here's the catch. Deep space images showed absolutely no visible dust or gas tail. None. It was accelerating without a visible engine. This was a massive anomaly. I mean, how does an object propel itself without leaving a single trace?
As you can imagine, this specific mystery sparked intense debate. So let's look at Section 4, the leading theories. A scramble of competing scientific hypotheses suddenly emerged trying to explain this invisible outgassing and its totally bizarre physical traits.
Let's rapidly break down the major theories attempting to solve this puzzle. 1. A nitrogen ice fragment. If Oumuamua was a chunk of an exopluto, the nitrogen gas burning off wouldn't actually be visible to our telescopes. 2. A body of hydrogen-laden water ice, where cosmic rays created trapped molecular hydrogen that outgassed invisibly. 3. It might just be the remnant of a disintegrated comet, essentially a loosely held together rubble pile. 4. A cosmic dust bunny made of incredibly lightweight, fluffy material. And 5. The hypothesis of an artificial alien solar sail, an ultra-thin object being pushed by solar radiation pressure. Now, many of those natural ice theories actually help explain its shape too. It's sort of like a tumbling bar of soap just wearing away into an elongated sliver as it loses mass to the sun's heat.
Now, regarding that last hypothesis, the idea of an alien technosignature, well, it prompted some immediate serious action from the scientific community. To test this out, powerful observatories, including the Green Bank Telescope and the Allen Telescope Array, actually dedicated time to scan the object across multiple radio frequencies. They were listening closely for any artificial signals or targeted transmitters. The results? They were clear. They detected absolutely no unusual radio emissions. While the broader academic debate about its exact composition is definitely still going, these rigorous scans maintained a strict factual neutrality, and they simply found no evidence of an artificial origin.
Which brings us to our final part, Section 5, the lingering mysteries. You know, the harsh reality of observational astronomy is that sometimes time is simply our biggest enemy.
Fading rapidly and heading towards the constellation Pegasus, Oumuamua dropped completely from all telescope views by early 2018. It just became way too faint, even for the Hubble Space Telescope. Our interstellar visitor is now forever out of reach, passing beyond the orbits of Jupiter, Saturn, and Neptune, and it's continuing its journey back into the interstellar medium at speeds relative to the Sun of over 58,000 miles per hour. It gave us a wealth of data, but inevitably, it leaves us with theories that we just can't directly test on the object itself anymore.
So, we end with this provocative thought. Oumuamua is gone forever, but its impact? That's permanent. When will the next messenger arrive? This single event radically shifted our awareness. It proved for sure that interstellar objects are passing through our solar system, maybe even as frequently as once a year, just previously hidden from our view. It introduced us to the whole concept of dark comets. And now that we know they're out there, our survey telescopes are more powerful and our cosmic fishing net is cast wider than ever before. The entire scientific world is waiting, hungry for the next discovery. Thank you so much for joining me on this explainer. Keep your eyes on the stars.